Hello. In this module, let's understand what is wire and what are the types of wires which are used in the wiring harness. As selection of wiring harness is very important decision taken by the design engineer. So in the first picture, there is wire called single core multi-strand wire. So what does the single core mean? The single core is nothing but the copper section. The copper section is a single bundle and it is in, inserted inside a insulation material which can be seen in red, white, blue and yellow color. So in a single core single strand wire, the copper is a thick barrel in construction and it is inserted inside the insulation. Due to this construction, the cost of the wire gets reduced, but the bending of the wires is reduced. The wire, the multi-core, multi-strand wire gets bent easily, but the single-strand wire is not flexible like the multi-strand wire. After that, there are multi-core cables used in automotive as well as many other applications like construction, automotive, as well as appliances. So, in a multi-core cable, there are separate insulations for each wire. So, as you can see, there is a copper part and the insulation part. Above that, it is together bunched by a black color insulation. Here there is a shielded cable. So a shielded cable is nothing but the earthing part which is done for the wire. So during design phase and designing wiring harness for sensitive equipments, the shielding of the wire is grounded to the chassis for eliminating any noise or any EMI EMC variations in the working of the application. The wire comes in multiple sizes, and with the size, the current carrying capacity of the wire depends. So, for a 0.75 square mm wire, the amperage is 5 to 6 amps. So, more than that, the wire will get damaged or heated up due to more current. So to eliminate that, there is further size 1 square mm wire. So the 1 square mm wire can carry 8 to 11 amps, and the thickness of the wire changes accordingly. So as you go below, thicker the wire, the more the current carrying capacity. So the 10 square mm wire carries more current than the 2.5 square mm wire, and the 10 square mm can carry 38 to 43 amps as per the chart. This is a square mm guide of the wiring, and there is also American wire gauge, which is AWG. So AWG is reverse of the square mm chart. So here the 0.75 square mm is the thinnest wire shown, but here the 40 AWG wire is the thinnest wire shown. So as the AWG number reduces, the size of the wire increases. As you can see, the 12 AWG is very thin wire, but a 6 AWG wire is a very thick wire. So depending on this, the appropriate AWG and square mm has to be chosen. So here another important factor is the temperature class rating of the wires. So the wire temperatures here is divided by A, B, C up to H class. So the A is the least temperature band wire. So the wire can be ideally working from minus 40 degrees Celsius to 85 degrees Celsius. As the class increases, the temperature rating of the wire increases. So the D class wire can withstand minus 40 degrees Celsius to 150 degrees Celsius. The temperature is a very important selection factor in the designing of wiring harness, and the temperature class has to be selected accordingly. Another important factor in the wire selection is the bending radius of the wire. So the bending radius, as is given in this picture, is not is nothing but the bend bend the desirability of the wire to get bent. So as we discussed, the single strand wire is not very flexible, and the bending radius is higher because of its single core construction. But on the other hand, if you take a multi-strand wire, the multi-strand wire is easily bendable and can be reduced in can be reduced bending for, and can be used in tighter applications which require wire to be bent at a steeper angle. So these are the important factors for understanding wire selections. Let us see what are the factors which are used for selecting wire as per datasheet. So here we will look at a wire datasheet which has all the required parameters and the classes for the wires. So as you can see here, this datasheet is from a manufacturer called CCAM, and the wire construction is shown here. So this is a multi-core wire, and insulation is above the wire. So let us understand what is the construction of the wire. So construction is conductor classification is soft annealed plain copper. So this is the type of copper, and the insulation material is PVC. So PVC material is the material which is used for the covering insulation. The color here is given as per customer order, which is given below, and we will discuss in the later. So the construction here is single core, single layer insulation, as you can see here, and the features of this wire are conductor stranding, which is the multiple strands, reduced diameter, thicker one insulation. So the diameter is less and the wall of the insulation is thicker. So technical data here is given as minus 40 to 100 degrees Celsius temperature operation. So as we discussed in the previous part, the temperature rating of the wire is minus 40 to 100 degrees Celsius. So suppose you want to use this wire in lower temperature than 40 degree Celsius, then this is not suitable. The standard of the wire is ISO 6722-1. This can be of multiple standards, and the standard applicable is usually given in the datasheet. So this is the construction part. So this is the part number of the manufacturer uh, of the wire, and here is the cross sectional area. So let's assume we want zero point 0.5 square mm wire. So let's understand what is the construction. So number of strand is 19. So the strands here for a zero point 0.5 square mm wires, the individual strands, if you count sequentially, it will be 19. Another factor is the diameter of the wire. Another factor is diameter of the single wire, of the single strand. So which can be 0.19 mm to 1 mm. The insulation wall thickness is given as 0.6 mm, and the overall diameter of the cable, means from this edge to the below edge, is given as 2.3. The weight of the wire is given in kg per kilometer, which is 10. Suppose 1 kilometer of wire is taken, then the weight will be 10 kilograms. Another factor is the maximum conductor resistance at 20 degrees Celsius. So this is the resistance of the wire, mm, which is given in ohm per kilometer. So the zero point 0.5 square mm wire has ohm per kilometer resistance of 37, and the ampere carrying capacity is 14. So the zero point 0.5 wire has ohm per kilometer of 37. In comparison of, let's say, 0.75 square mm wire has ohm per kilometer of 24. So as the size of the wire increases, the resistance decreases. So the 120 square mm wire will have resistance of only 1.53 ohm per kilometers. So the thicker wire you choose, the flow of electrons will be easier and the resistance is lower. Here is the current carrying capacity in amperes. So zero point 0.5 square mm wire as per the manufacturer is 14 amps, and 120 square mm wire is 675 amps. These are the standard lengths given by the supplier or the manufacturer, which is 1000 meter or 1 kilometer. Let's understand the color coding. So the XX part given here is the color. So if the designer wants the red color wire, then the part number will be A8310601. So this is required for ordering the wiring for particular color coding. So these are the important factors for selecting wires and understanding its types. Thank you.